let's start up. And I plan on starting today in by going through the dates example, the fun with dates that I mentioned last time. A lot of people, for whatever reason, have trouble with dates. So that's why I wrote this example, and we should have time to go over this today. I do have another inheritance example that I do want to get to. If we don't cover it completely, you can take a look at it and try to figure it out on your own, try to figure out what parts we didn't go over. It is in the week 7 module, and it's just called Sales Rep Zip. At any rate, we have this code, and let's see what we do. Here, we're going to run down the line and see what we do. First thing I do is I create a date and initialize it to now. All right. This one, I create a date and I initialize it with year, month, day. This one I do the same thing, except I use a static variable, a constant, for July. And then I print it out. Here, I compare to see if date 2 equals date 3. That might be a bit of a trick question. This one I look and I use the equals function to see if date 2 equals to date 3. Here I add 28 days to date 1 to get date 4, and I output date 4. So in other words, date 4 should be today's date plus 28 days. I look to see if date 4 is after date 1, which it should be, of course, because it's 28 days later. Sounds like a good name for a movie. And I either print out that it's after or it is not after. I look at the difference in days between date 1 and date 4. I look how long it is from date 1 to date 4 in days, and I don't know why I did it twice. I think I meant one of these to be years or months or something, I think. But we can play with that if we want. So I'm going to compile this, make sure that it works, and then away we go. Oh, it's right on the desktop. I would not recommend doing that, but oh no, the directory is actually called Fun with Dates. Interesting. And then there is the Fun with Dates class that we were just looking at. So let's compile it. And I lost my mind, and I typed compile because I was saying compile. Let's try that again. You know, I keep my mistakes in the videos for the most part. Last week I ended up re-recording a video because it was a bad lecture for me. But I usually keep mistakes in. If nothing else, you know, just to show you, you know, hey, I've been doing this how long and I still screw up. So, you know, don't feel bad if you're confused about something or whatever. All right. So now we'll execute it, and then we'll look back and see if it gives us the results that we expected. All right, 2022, 228. That, if you recall, was, let's try to put these side by side. That is the result of creating a local date with the word now and printing it out. That gives us 2022 to 28. Both of these give us the same thing. 216 July 4th, 216 July the 4th. So we could create them either way that we wanted to. This one is interesting. I look at them and I say, is date 1 or is date 2 equal to date 3? Notice they both have a date of 7/4/2016. Yet it says that they are not equal. This is a key point. Why are they not equal? Yes. Memory is comparing the memory location of those date objects. In other words, they are not equal because they don't point to the same date object. They point to two different date objects in memory. Now, if I were to do this, then I'm going to take the memory location that the date 3 object's in, put it in date 2, and this should tell me that they are equal. Sure enough, it says that they are equal. So when you're comparing two objects, remember, you are comparing the memory locations for the variables. Where do those objects live in memory? And if there are two different objects that were created at two different times, the date object is a little odd in that it doesn't explicitly use a constructor. We call date local date dot now, we call a static function or local date of. I can't give you a good answer why they do that other than to say that they do that. But these two separate objects are created. And therefore they show up as not being equal. Now the equals function, on the other hand, does show up as being equal. Date 2 does equal date 3. Because using the date equals function, it doesn't look at which object it is. It looks at the value of the object. And under what conditions are two dates equal? Well, if their days the same, if their months the same, if their years the same, then they're the same day. So they wrote, whoever created this class created an equals function. And we've seen that earlier in the course with strings. We use strings. When we use strings, we use the compare method to compare them as opposed to saying simply, does this equal that? All right, local date 4 is date 1 plus 28 days. Shoot. So much going on the screen at the same time, and they're not particularly big screens. Anyhow, 28 days, and then we print it out. It'll show me 28 days from now, which is 3/28. 3/28 is indeed 28 days from today. I ask if it's after. It says that it is after date 1, or date 2 rather. Yeah, date 1. It gives me the days difference in years. And it tells me how many days it will be from date 4 to date 1. There's 28 days between them. What's the difference? How many days there are between date 4 and date 1? I suspect what I wanted to do here is show months. And it will show me that there's 1 month difference. What if we use year? It says 0. It must round. Pardon me? Oh, how I declared it? I declared it as a long, yeah. So that's a long integer. Let's declare it as a double. Good point. Oh, no, it still says 0. I'm surprised with that, but it must round it. Let's instead of 28 days, let's do 280 days. By the way, what I'm doing here is a great thing to do. If you want to see how things work, just try it out. I'll bet it does. I'll bet it does return an int. And even with 280 days, it doesn't round it. So if I did 366, presumably it would do that. But what I'm doing here is I'm testing it. I'm taking and playing with it. I get questions from students, and I don't mind questions from students. I don't want to make it sound like they upset me, but I get questions from students like, well, what will happen if I make that an integer? Well, the compiler and running it will tell you a lot quicker than I will, right? So just take a shot. Like, if you don't know how something works and you think maybe something will work, give it a shot. You know, this is my, once per week reminiscing about the good old days. This isn't like the good old days when I had like a day turnaround time on my programs, when I would take my card deck and put it in the mainframe, and I might get my answer in a few hours if I was lucky. If not, I might get the answer the next day. All right, that's literally true. So we were really sure. We looked things up and made sure we knew what was going to happen before we ran that program. Otherwise, you're wasting a day. Whereas here, you can run it instantly and see the results. So take advantage of that benefit. Any questions about any of this? Apparently, it truncates when you say the difference in years. All right. The other example we're going to look at is another sales rep, another inheritance example. So I'm going to go to the command line. I'm going to compile these. And depending on the time, we might play some what if games with this one. In other words, what if we do this? What if we do that? Apparently, I am not practicing what I preach. I only tested one test case. All right. Maybe we can talk about generating test cases here. All right. Okay. So let's look at these classes. I'm going to start with unit tests, not particularly exciting. Sales rep. Junior sales rep. And senior sales rep. All right. Now, senior sales rep extends sales rep. Junior sales rep extends sales rep. And sales rep is the base class. Does that make sense to you? And why does it make sense? Yeah, go ahead. Exactly. A sales rep and a junior or a senior sales rep and a junior sales rep are both sales reps. Now, I did not do it in this example, but I could have made sales rep an abstract class. What does an abstract class mean? Exactly. Let me run down and say that typically you only have abstract methods in it. All right. I do believe you can put default methods in them now, I think, and code it. I know you can with an interface, but let's forget about that. With an abstract class, you have typically a bunch of abstract functions, which means that you cannot create an instance of an abstract class. All right. So why did I not make an abstract class here? Well, because there's a type of sales rep that's just a plain old sales rep. If I made an abstract class for sales rep, I would then inherit from that to just be a regular sales rep, and that seems like an unnecessary layer in there. All right. Therefore, since there are really sales reps that I would need to create an instance of and call the methods on, I did create it not as an abstract class. It does make sense, as was stated, that the junior sales rep and senior sales rep are extending sales rep. Why? Because they both are sales rep. The statement that senior sales reps is a sales rep makes sense. Junior sales rep is a sales rep also makes sense. Therefore, it makes sense for them to interface, to extend each other, rather. Now, this is probably grammatically incorrect, but bear with me. There's a strong is-a relationship between sales rep and senior sales rep, or sales rep and junior sales rep. In other words, it isn't any stretch of the imagination to say a senior sales rep is a sales rep. It's right in the name, all right? Just like a graduate student. A graduate student is a student. It's right in the name. Now, let's say for some strange case. We kept track of, we're an insurance company, and we kept track of drivers, let's say. This is a little far-fetched, all right? But let's say we do. Now, a senior sales rep is also a driver, right? Because they drive a car. So that statement is correct, all right? A junior sales rep is a driver. A sales rep is a driver. Would it make sense to make a inheritance between sales rep and driver, or junior sales rep and driver? Why not? Yeah, you're not interested in the driving aspect of this person, all right? In other words, yes, they are, but that's what I would call, in this case, sort of a weak is a relationship. Yeah, it's true, but it's probably not terribly relevant, all right? Now, we could have a class of employee that sales rep inherited from, and that would be okay because a sales rep is an employee. But a sales rep is a driver, but that's kind of a stretch. So when it's kind of a stretch, I call it a weak is a relationship. And when it's really something that's really there, I would call that a strong. So we're looking for strong is a relationships. And as you said, one of the ways we know it's strong is if they share behaviors that they both do that we're interested in. So we're going to be interested in calculating the sales rep's salary and the sales rep's commission and maybe other things for the sales rep. So yeah, they all share, they all make sales, and they all get a salary calculated based on the sales that they made, more than likely. I forget the logic in this, but it probably depends on what they've sold. So it doesn't depend on like how many tickets they've had as a driver or whatever. Besides that, that's like the more programming answer. Besides that, in a way, it's just a good idea to put your, layperson's hat on and say a sales rep is a junior sales rep is a sales rep. Well, yeah, of course it is. So if your answer is, yeah, of course it is, then it probably makes sense to have it as strong as a relationship. If your answer is sort of like, I guess you could look at it that way, you're not wrong, but then that would be a case where I would not do inheritance. Now we're going to study something next week that kind of covers those. Well, it's kind of that if it's relevant to the problem that we're trying to solve. Maybe, for example, we do want to track the tickets of our sales reps. And we want to track the tickets of whatever. All right, I'm just sort of making this up as I go along. Then you would use some other technique. Yes. Right. Exactly. And what's different, what's an additional concern is maybe other people get company cars. Maybe if you're what would be example? If you're in upper management, so if you're a CEO, CFO, whatever, you get a car. Maybe if you are a senior accountant, you get a car, but a junior accountant, you don't. Could be all kinds of possibilities where throughout the inheritance structure, there's things they have in common, but it's not something that all employees have in common. So you might be able to create something, they're called interfaces, and we'll talk about those next week, where you might create a driver of a company car interface, all right? And then you can associate that with the classes that are drivers of a company car and do processing like that. Absolutely. Right. Yeah, you could look at it that way. The student mentioned that there's a strong resemblance between this and the relationships in the database. And you're absolutely right. We don't necessarily have keys in here, although we could, right? Sales rep number, I don't have in my example, but that could be a key. Or employee number, if we wanted to take it that far, could be a key, and so on. All right. And you're right, it's very, very, very much like database relationships, but it's on the coding side. Now, how many of you have taken CISS243? When did you take it? Do you remember? Right, web database. Yeah. Okay. Okay, you're in 243 now. For the benefit of students that have had it recently or are taking it now, mapping between objects and databases is an important thing, all right? And that's exactly what we do with ASP.NET Core. We have our classes to retrieve the data, and that might have contained in it relationships and other things like, an optional relationship that an employee could have a car, all right? Or a list of persons that a supervisor supervises or something like that. We put that in a relationship, and then that is mapped to database tables. So if I say retrieve this sales rep, I still have to have a key, but it will go and it will fill up that object. And then I can manipulate the object, and I can use link queries to query a table, and it's really sort of querying objects. So it's really cool, but you exactly hit on it. There are definitely parallels between those two, and object to database mapping is really the way that that's kind of handled. All right. So interfaces will come next week. Remember, you could only extend one class. All right. Now you might have several in a chain, like senior sales rep could extend sales rep, which itself extends employee, which extends object. So yeah, you could have a chain of multiple extends, but you can't say that a sales rep extends employee driver and sales rep. All right, that multiple inheritance on the same level is not allowed. What we'll talk about next week is interfaces, where we kind of get around that problem. All right, we'll talk more about that next week. All right, let's look at our base class. Our base class has 3 attributes: employee ID, a name, and a sales amount. And we have our constructor that sets those attributes. We have our sets and gets. And the default commission is, for a sales rep, is 10%. All right. And in addition, the base salary is $2,000 a month. So the total salary is $2,000 plus their commission, whatever that is, and that'll give you their base salary or their total salary. Now, one thing I should do is I should practice what I preach. What's a better way than saying emp ID equals arg emp ID here? No, this is a base class. We can actually call the set method. That's why if later on we go and add some validation here, we don't have to duplicate it up here, because everything goes through the set methods. This is a little difficult to see in like a classroom environment. But keep in mind that when you're making these classes, when you're done with them, you release them to the world, all right? If not the world, to your programming department, right? So other people that other than you are going to be using these classes. Now, you might know that an employee number has to be even, all right? For some reason, every employee number we generate is even. I don't know why, it's just the rule, all right? And you might make sure that your programs always feed an even employee number to the constructor, all right? However, the next person that comes down the line is going to forget about that, or is likely to forget about that. Therefore, you want the control built into your program. So one way to do that is anytime you want to change the value of a variable, use the set statement, even in the constructor. Doesn't change the results in this case, but if we add validation here, and maybe add exceptions, then you can't sneak one past this class, all right? You can't slip in through the constructor and give an invalid value to one of these attributes. It's for that same reason that you make these protected, all right? And you could argue that these should be private. Well, if we make them private, what does that mean? That means that nothing that inherits that can use that variable. So I can't use sales amount times 0.075. What could I do instead? I could call the method. Whoops. So let's do that. Okay, I'll look at that in a second. Let me finish my thought here, otherwise I'll forget. And I'll be looking for my error for an hour. Okay, so here in the constructor, we're referring to the argument that gets passed. And in the base class, oh, set and net, yeah. That's what happens when I talk as I'm typing. I might say a word, might type it, even though it has nothing to do with it. All right. So let's see if this works. Shouldn't make any difference, all right? But keep in mind that someone else is going to come along later on and maybe make a new sales rep class that inherits. And they may not follow all the validation rules if you can address that variable directly. Therefore, making it private and going through the method is definitely a good idea. Because then all the validation will be here and anywhere else, along with anywhere else in the subclasses, has to go through this method to manipulate that attribute. So I think I took care of everything. Let's see. Oh, in sales rep. Senior sales rep. Okay. I shouldn't get it in sales rep. I was going to say that has. Oh, okay. There you go. Thank you. I was looking in the if statement. I thought that was the only place I referred to it. These, in my mind, the stuff that we're talking about today with that is kind of like the, what would I call it? Like the finer points to it. They're not, you know, if they were violations of the law, they would be misdemeanors and not felonies. Okay. Making your attribute public is a felony. All right. Making it protected, well, that might not be the optimal way to do it, but it's not horrible. All right. But the best way is to do it this way. All right. And I thought I'd at least bring this up in one example just to show how that's done. All right. Let's follow through. We went through the sales rep class. That sales rep class and their attributes are very well protected. Junior sales rep. We override the base salary. The base salary for a regular employee is a regular sales rep is $2,000. For a sales rep, it's $1,500. And the commission is 7.5%. Senior sales rep, base salary is $2,500. Commission is calculated on a little bit of a rule, all right? They get paid 12.5% interest on their sales amount, but if they sold more than $10,000 worth of goods, they get 2.5% more on the amount sold over $10,000. Base salary is a method. You're right, it is a field. So I probably should do this. No, wait a minute. No, it's not an attribute. Yeah, my mistake. It's calculated. All right. As far as constructors go, let's look at the unit test. I'm calling new sales rep and I'm passing these 3 constructors. That should be no different than what we've done since the beginning of the course. We have a class, we set the ID, we set the name, we set the ARG salary. And in this case, if I call the constructor for the junior sales rep, it does the same thing. All right. Now, what if? What if I remove that constructor? Is it going to run and give me screwy results? Will I get an error or will it work just fine? Pardon me? Okay. This is what we have for sales rep. Yep. Right. Let's see. I see what you're getting. It doesn't know how to set up the sales rep to begin with, let alone a junior sales rep. So let's see if we know what's wrong. Let's see if it compiles. Let's see if it runs. And let's see what that message it gives us. Okay. Junior sales rep. constructor sales rep in class cannot be applied to given types. Public class junior sales rep. That requires an integer, a string, and a double, but it got no arguments. What's this no argument business? Not just that, we don't have a constructor defined for junior sales rep. So the default expected no, and it's going to call what? It's going to call the parent's no argument constructor, which doesn't exist. And it tells me it's looking for, in junior sales rep, is looking for a no argument constructor, and instead the only constructor that it has requires an integer, a string, and a double. Repeat that, please. Right. Well, keep in mind that right now, all the unit test is doing is creating a sales rep. So, in other words, it's telling you there's a problem with junior sales rep, regardless if we were using it anywhere or not. Now, okay, so we add the constructor back in. And we say, you know what? I can't remember how you call the parent class's constructor. I'm just going to do this. So I make the junior sales rep's constructor do exactly what the parent's constructor did. All right. It is going to take the argument, set it as employee ID. It's going to take the name and set it as the name, take the sales amount, set it as the sales amount. What will this do? Your three choices are compile error, run but problems, or run correctly. Well, those might look like problems, but that's not actually the problem part. Neither of those two things are the problem part, because if I call this set ID, since it extends it, the superclass's set ID is the set ID for this object. Likewise, yeah. So therefore, that is not the problem. But you are right, there is a problem. And what is the problem? Well, let's compile it and see. Oh, I forgot parentheses somewhere. So take two. Looks suspiciously like the last error we got. It's telling me that constructor and sales rep and class sales rep cannot be applied to given types. It needs an int, string, and a double. It got no arguments. What's up with that? Okay. This is really confusing, so don't feel bad if you have thoughts in your mind. Maybe go over the lecture a second time and play what if games like this on your own projects and see. Here's what's going on. It's the law that when a constructor on a subclass is called, the constructor for every superclass is called. All right? So far, so good. It worked before when I said super and did the constructor and passed these three arguments up to it. It doesn't work when I do this because I don't specify which constructor to use on the superclass. It still has to run one. I haven't specified though. Therefore, it will try to run the no argument constructor on the superclass. And that no argument constructor doesn't exist. Right? Just the fact that I don't have super here doesn't mean it's not trying to run the constructor on the superclass. It just doesn't know which constructor to call. Therefore, it tries to call that default no argument constructor. If I do this, on the other hand, it knows which one to call. All right? The three argument one. And therefore, this is going to compile just fine. Now, we'll do a couple of things here in our last minute or so of class. What if I do this? Is that legal? Yes, it is. It's legal because I'm creating a variable that's going to hold a sales rep. Doesn't matter what kind of sales rep. I'm creating a variable that's going to hold a sales rep. What kind of object am I creating? I'm creating a junior sales rep object. But that variable can hold a pointer to a junior sales rep object. It can hold a pointer to any sales rep object. Now, what will it do the calculations, though? How will it do the calculations? Now, because this overrides this, it will take the junior sales rep's version of that function. All right, that's exactly what polymorphism says. So if I compile it and run it, compare this to the last one that we got somewhere up here, 2,500, 1,500, 375, that's the junior sales rep money. So remember, whatever you create it as, it gets those versions of the functions that they have in common. Now, what you're thinking of is you couldn't call a function that existed on the junior sales rep that did not also exist on the sales rep one. So if I had a, get end of probationary period or something like that, all right? If that only existed on junior sales rep, if I declare this pointer as a sales rep, I can't call the methods that are defined only on the junior sales rep level. And again, if you think about it, it makes sense. Yeah, we've created a sales rep object here that contains a junior sales rep, but a lot could happen between here and there, all right? You could create another variable and assign it to that. Therefore, the compiler says, hey, I'm not going to try to figure out your code for you. If you're saying it's a sales rep, I'm only going to give you sales rep things, all right? But I will give you the proper version of those things. All right, it will give me the junior sales rep version of those things. We'll probably, yes. 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 Because remember, it creates the entire object. It creates it as a start from the base class, and then it finishes up with the subclass. And if there was more, it would just keep doing that. All right. Well, whatever level you define, this determines what function you can call. This determines what versions of the function you can call. I think is the simplest way that I can put it. Now, this is going to become relevant. And again, why would we want to do this? Because maybe we want to create an array list of sales reps, but there are all kinds of sales reps that get created all kinds of different ways. And we want to process through that list of sales reps and calculate your total salary. All right. So we could create an array list and populate that array list with some juniors, some seniors, some regular sales reps. And we could loop through and for each one ask what the total salary is. And it will do it because get total salary is a method on the sales rep. So since the array list of the sales reps, I could do sales rep things to that. And therefore I could get a sum of all the salaries, even though some of them were one kind of sales rep, some of them were the other. You could if you needed to do that. For example, let's say I'm preparing a report, and that report just had like name, employee ID, and total salary for the month. All right. If I did that, I wouldn't have to do any casting at all. But if I wanted to show for a junior sales rep what their probation date was, or what their hire date was, or whatever, and that was only available on the junior sales rep, I would have to, in that loop, check the type of the object, determine what type it is, and if it was a junior sales rep, then display that information. You're right. Right. Exactly. Exactly. It's confusing. I think this is something that you could probably hear me or other explanations, but really getting in and getting your hands dirty and doing things like this, I think will really show you and getting the errors. That's why I tried to make some errors, all right, so that you could see, like, sort of read between, the lines and to figure out exactly what the error is. All right, are there any other questions? All right, that's all I had for today. Next week, probably more on this, but specifically dealing with interfaces.